So let's go ahead and build this tree and test it and find out where we failed. Okay, so currently we have this tree, apple, hello, world, zebra. We can try building art, but let's go ahead and throw this out and work with the tree that I've been writing up here, which is, let's go with, yeah, 0. So let's go with this tree. So 5, then I'll put in 1 and 12, just to make sure that the order stays the same. So 5 will be the root. We've got 1, 12. Well, since we could do 0 and 2 as well. So we'll add all the items to the left. Tree.add. And the reason I have to follow this in this order is because we want to make sure that that when we add 3, it comes after 2, so this is going to be to the right of 2, as opposed to 3 and then 2. 1, 2, 3. Okay, and then I'm going to go ahead and do 5, 12, 7, 15, 4, and 20, 14 and 20. Okay. What about making sure that this is in the right order? Well, let's go ahead and do it in pre-order notation. So 5 should come first, then 1 and 0, 2, and then 3. And then 12 should be the root of the left subtree with the children of 7, 15. And then 14 and 20 is 15 children, which is fantastic. Okay, so now let's go ahead and test all the parts of our delete method. So let's go ahead and do tree.remove. Let's go ahead and test deleting a leaf node. Let's go ahead and delete 3. So we still have 5, 1, 0, 2, 3 isn't there anymore. Then we have 12 as the root of the right subtree. Then we have 7 and 15 and 14 and 20. So it didn't affect anything else. Let's go ahead and delete 20 just to show. Right, we only want the thing that we're deleting to be deleted. Let's go ahead and try deleting something with only 1 child, which the only thing on that tree is 2. So 3 is still there because it was now 1's right subchild, so boom, printed that out. Okay, next, what do we need? We need to delete, let's try deleting 5, and we'll replace it with 3. So now if we delete 5 from the tree, uh-oh, what happened? Well, we printed out nothing, so that means that we've got null. So what did we forget? Oh, right, I didn't return anything, and I have a return null here. So that probably did something not fun. I never returned anything. To return to whoever called me, fixed it. So I've fixed this item. So what do we have to return? Have to return something here, right? So root.item, right? We've replaced the root. Oh, right. So if we are at root, root's asking what are we going to return for root? Well, we've replaced it with a new item, so we're returning ourself. Ta-da! 3, 1, 0, 2, 12. So the hierarchy still works. I'll be right back. I'm in the middle of finishing up one of my recordings. It's fine. They needed a couple of seconds to process it anyway. Okay. So now we've got this working. Okay. And it's working perfectly, except we have one edge case that we didn't think of. Let's go ahead and change our tree a bit by adding one item down here by changing something. Instead of adding a 3 over here, let's say this is a 4. Oops. Let's say that this is a 4 over here in our tree. You thought you were done with this method. We've got a 3 over here. Oof. Okay. So still, if we were to delete the next order, if we were to delete 5 and get the next in order successor, 7. Here, if we get the next in order successor, it's 4, but 4 has a child, which is 3. What do we do in this case, right? Well, the reason we said we can just copy this over and then delete 4 because we said that's an easy case, where 4 basically is, because 4 is a leaf, we can just simply delete it without messing with anything. But now it's got something to the left. It's never going to have anything to the right, because if it had something to the right, that'd be the thing we're actually deleting. Or if we had something to the right, that would become our new root instead of us. So we'd only have one child to the left ever. So how do we handle that? Well, this is the case of deleting again, we'd be basically replacing 5 with 4, and then we'd want to delete 4, which is case 2, which is deleting something that has a left subchild, which is, again, an easy case. We just simply replace us with our left subchild. Okay, so instead of saying parent of successor, our parent's right subtree, instead of saying 2's right subtree is null, we'll say that it's our left subtree, which may be null, which may not be null. Or left subtree. So yeah. So successor dot left. In this case, so again, we're adding a 4 here before we do anything else. 4, 1, 0. So now 4, 1, 0, 2, and then 2's child is now 3. Then we went to 12 and replace the rest. Does this work on other nodes besides the root? Let's check it out. Well, instead of removing 5, let's delete something else which has 2 children, right? Let's delete 1. Well, we'll do what's 1's going to be replaced by? Well, its next in order successor is, or predecessor is 0. You see, I messed up my terms here. Jeez, that's embarrassing, and I've already done a bunch of videos. Technically, this should be root of left subtree, parent of our, it should be a parent of our predecessor. Ugh. You see, if I was in class, somebody would have caught that. That's what happens when you work without a script, Andrew. Regardless, let's delete 1. In that case, it's going to be delete by going to the left and all the way to the right, which will be 0. Oops, got 2 zeros in there, so we've messed up somewhere. Okay. So 5, 0, 0. probably has to do with the fact that basically there was nothing to move to the right on. Let's go ahead and rewrite this so that it is correct, parent of predecessor. So yes, I probably do a replace all operation, but okay. Okay, why is my indentation lined up? Not lined up. There we go. Okay. So parent of our predecessor, because we're going for the next in order predecessor. All right. Root of left subtree is root.left. Parent of predecessor is equal to null. Predecessor is equal to null. So if the root of the left subtree is, if we go to the left and its right subtree is null, we say that parent predecessor is the root. Predecessor is the root left. So we go down over here and we say root.item is equal to predecessor.item. We say, so here we're saying, move this up into the root. And our right subtree is equal to our left. So what we want, so we want this in here. And unfortunately, this will get obnoxiously long now. So instead, what we want, this only works for, this bit of code only works over here. I go one to the left, and I find that basically that's as far as I can go. And what am I going to do there? Parent predecessor is root. Predecessor is equal to root of left subtree. Let's go ahead and so I go one to the left. That's as far as I can go. There can be other stuff to the left. So I'd say basically that root.left is equal to all this is unnecessary for here. Root.left is equal to predecessor.left. And before we do that, root.item is equal to, sorry, all of this was unnecessary over here. Root of left subtree. We don't have to copy, and we aren't copying, so we're copying over the item into the root to replace it. We're copying over, we're making the left subtrees root item R, sorry, left subtree R subtree. Now we run it. Deleting one worked. Okay. So that's our deletion method. Finally and fully complete.